Hello everyone. The fourth video with designing step is starting here. It is the final step of our series of videos that how we ultimately design a model and what are its perspectives. First of all, go to the design. First of all, select all the members and go to design and concrete from design, and then click view revise overrides and click on element type, which type of uh, structure you are constructing. Then click sway, and I am constructing sway intermediate, that's why I click on this and then press OK. Two types of structures are generally designed in ETABS. One is steel structures and other is RCC structures. I am discussing all about concrete structures. The other thing is that design concrete frame design. Select combo for if I am designing the whole structures for all combos generated by ETABS by using code, assigned code. If you are designing only for ultimate, then of the decoin 2 and design and delete other combos. I am designing for all combos, and the controlling one would be choose later. So options, go to concrete frame design and choose your code for which you are designing, and choose a seismic zone for on where you will construct your design structure. Okay, then go to design and click on concrete frame design, then start design, check of structure. This step takes a little bit time, that's why I am squeezing video here. It will be continued later. The design is being completed and reinforcement shown by ETABS. First of all, the thing we have to check is that whether the all cross section is passing or failing. If it will passing, it will show in colors like this color and the green color. If it fails, it will be shown in red color. In our case, all the cross section is passed, so congratulations to you. If it fails, the question arises here is that if any cross section fails, then what we will have to do. If let me explain one thing here is that the lateral load is resisted by the combined effect of two structural members, column and beam, and their joint is fixed. If the depth of beam is more than column, then maximum moments would be taken by beam, and less moments would be taken by column. The result will be affected by beam instead of columns. Therefore, it must be necessary to approximate limit the combined effect of beam and column must be resisted by both members. Let me tell you that if a beam fails, then its failure is of two kinds: flexure failure and shear failure. If it fails in flexure, you will have to increase the depth of beam. If it fails in shear, then you will have to increase its width. And if a column fails, then this will also leads to the failure of beam. That's why because it's a it's a combined effect of column and the beams. Therefore, to pass a beam, the columns must also be passed. If column fails, then you will have to increase its cross section so that it will get more stiffness against lateral loads. Let me show you that how we will know whether a beam is failed in flexure or in shear. Right click on the failing beam. In our case, no beam is failed, so for only to show only methodology, click on the beam and right click and go to flexure details. Here flexure reinforcement for moments are given if it will fail in flexure, and here the instruction will be displayed that your beam is failed in flexure, then you will have to increase depth. If it fails in shear, then notification will be here that your beam is failed in shear, then you will have to increase the depth. I think you all are astonishing about this, that how we will increase the cross sections. Let me show you that how you can increase the cross section of structural members. Let's suppose this beam was failed in flexure. 10 by 24 was failed in flexure. Then select this, go to assign and then frame line. Because your model is run, you will have to open this first. Go to assign, then frame line, then frame section, and then 10 by 24 and go to modify and then increase 24 to 28. This will ultimately pass your model in flexure. If it fails in shear, then again click on this, right click on this, go to assign and frame line, frame section, and go to that beam and click on width, increase the width 10 to 12. This will increase the stiffness and it will be passed in shear. If a column fails, then turn off beams and click on this thing, select a column and go to assign. I will have to turn off the object fill also. It's selecting other areas. Select and go assign, frame line, frame section, and then if I want to increase the cross section of this thing, then from here you can change 44 to 44, then press OK. It will increase the cross section and it will get more stiffness also. Let me turn back to this reinforcement. One more thing is that if you want to check the reinforcement of columns, then you will have to click on this thing, and by zooming you can see that how much area of steel is required for columns. 106.836 area is required. This is all longitudinal reinforcement is being shown here, and if you are optimizing a model for a specific range of reinforcement, then you must have to turn it. Go to design, concrete frame design, and display design info. This was only longitudinal reinforcement. Click on rebar percentage. Then if you are optimizing a model for a specific range of percentage, let's suppose I optimizing a model for a maximum of 6 and a minimum of 2, then I will have to change the cross sections so that reinforcement will be near to the optimizing limit. If you want to increase the reinforcement of any cross section, then you will have to decrease the cross section. If you want to decrease the percentage of steel, then you will have to increase the cross section. I think you have got this information. There are two perspectives to decrease and increase the reinforcement. If you want to increase the reinforcement, you will have to decrease the cross section. If you want to decrease the reinforcement percentage, you will have to increase the cross section. By this perspective, you can optimize a model to a specific range of percentage of steel. And the other thing is it is necessary to check the reinforcement of beam, whether it is in the range of minimum to the maximum limit or not. This is a percentage of steel being shown here. You can check this and compare with the all tables given by Nadeem Hassan in the last chapter of F4 table. You can get results from F4 table and compare it with the maximum value of this thing. If it is less than the minimum limit given by Nadeem Hassan in F4 table, then you will have to follow the minimum limit. If it is a maximum limit, it is a more than maximum limit, then you will have to follow maximum limit. In our perspective, the limit is between minimum and raw maximum, so no need to check it, no need to various information. I want to show you that thing, that table given by Nadeem Hassan. It will take time, so I squeeze this here. This is a table given by Nadeem Hassan in his book of Steel, RCC Steel 4th edition. This is a raw balance. This is a formula for raw maximum, and this is RU. And all the limits in our case, Fy is 60 ksi and Fc prime is 4000. The maximum raw max will be 1.806 and minimum would be 0.33. That's why we will have to calculate raw minimum and raw max, and our results must be in this limit. You can check here, page number is also displayed, table name is also, and you can compare the results more easily. Till now we have discussed only about longitudinal and percentage of steel. The other things are also in display design info. If you want to check shear reinforcement, then click on this and press OK. This shear reinforcement shown is a 0 here. It doesn't mean that the beam is not showing shear reinforcement. If it shows 0, it means that the minimum criteria is governed and you will have to provide the minimum shear reinforcement. This value, some value is being shown in upper stories. Let me show you. Now concentrate on this thing. Here is this value given by ETABS is a AV divided by S. Its unit is inch square per inch. And the value must be calculated by the formula given by Nadim Hassan in his book, fifth edition. Uh, from there, by using beam width, the minimum value for AV divided by S must be calculated and must be compared with this value. If AV divided by S calculated from minimum criteria by using the formula of uh, Nadim Hassan, if that value is less than this, you must use this value. If minimum value is more than this, you must have to provide that value. All three values are nearly equal, so we always provide maximum value from here. So this was guest knowledge about the general steps followed while modeling ETABS. The information discussed here was not information of whole ETABS. Of course, this is the general steps which will be followed in all kind of structure model you will design in ETABS, whether it is a RCC, whether it is a steel structure. Now it's up to you. The general steps has been delivered to you. You must follow the whole steps and construct one model, and more deep knowledge will be given to you if you first made that model, and if you will share your problems, then more knowledge will be communicated between us. So thank you for listening the whole videos. More videos will be given to you, like how to construct shear, how to design shear wall, how to analysis is done for wind and the other cases, and how other parameters are controlled, because in a short video these whole things are impossible to be discussed. uh, that's why I only generally focused on the general steps. So hope you will get some benefit from here. I again request you to construct a model by yourself and follow these whole steps. If you face any problem regarding modeling, then you can easily ask, you easily communicate. Thank you. Goodbye.